Good morning, students, and welcome to Radco Academy. And in this video, we are going to look at these specifics. We'll look at the use of radioactive isotopes, and then we also look at electronic configuration. We also look at chemical bonding, and then also look at definition of what is bonding. Okay. And then also look at types of bonding. Look at types of bonding, and then also look at the characteristics of these bonding. Okay, so now just to begin, now before we start, some of the session of what I'm going to discuss in this video are there already on our YouTube channel, so please find time to access them so that you can gain full understanding of this topic. Okay, so now let's begin the use of radioactive isotopes. So when you look at isotopes, what are isotopes? So first of all, these are just you can just say elements of the same proton number, element of the same proton number, but different mass numbers. Okay, so this is a definition of what an isotope is. Now you also have to understand, for instance, some of the notable isotopes we have, for example, carbon, and carbon as a symbol of C, and when you go on the periodic table, it's written 12 and 6. So apart from this one, we also have carbon 14 and 6 again. So you can notice that it has the same proton number but different mass number, and this is what we call an isotope. Okay, now what are some of the uses? Okay, so uses of isotope, number one, they are used in medical treatment. Okay, now remember that some of these isotopes are radioactive. So radioactive meaning they produce some rays, okay, some rays such as the alpha, some beta, and then also some gamma. So now it is these rays that enables these substances, isotope, to be able to be used in medical treatment of cancer, because it's very difficult to just treat cancer. So these isotopes we are looking at are radioactive in nature, and by that radioactive we mean that they produce these rays such as alpha, beta, and gamma. So come and look at in details concerning these uses, these radioactivity in physics. And then now what about apart from this medical, they are also used in industrial use as tracers, okay, as tracers. So they can be used to trace something. It can be implanted in an organism, for example. So you can say can be implanted in a human being, okay, human being or plant. So it can be used as a tracer to trace some of the things that cannot be easily seen and can be just connected to the computer system. Okay. Now let us move on and look at the chemical bonding. Okay. So what you need to understand about bonding. So bonding is simply just the formation of compounds. Okay, so elements combine together. Okay, elements are going to combine together to form a compound. So this is the combination. This is the combination of elements to form a compound. So bonding is the combination of elements to form a compound. Now we also know that there are types of bonds, okay, that we need to discuss. So the types of bond, you can simply just say okay, so when you look at types of bond, we have what is called ionic bonding. So under ionic bonding, so this one you can just say a bonding that involves a metal and a non-metal. So in this case, for instance, you can have sodium. Okay, you can have sodium and chlorine. So you can have sodium and chlorine combining to form a chemical bond, to form a compound. So in this case, so you have to note that a metal will lose electrons while a non-metal will gain electrons. Okay, and in this case, you have to take note that since sodium is in group 1, so for example, we write something like this. If it is just in group 1 and chlorine is just also in group 7, you just write like that. Okay, so meaning this sodium is going to transfer one electron to this chlorine. Okay, so we shall dive into the details of that. And then now about ionic bonding. Okay, so this ionic bonding is also called it is also called electrovalent. Okay, electrovalent bonding. It's also called electrovalent bonding. Okay, and then what you need to understand also is that in this ionic bonding, what are some of the characteristics? So we say they are solid at room temperature. So they are solid at room temperature. Okay, and then meaning they have high melting point. Okay, they have high melting point, and they also form ionic compounds. By this we mean, for instance, in the case of the above example, going to form sodium chloride. Okay, and then the other thing is that when you look at these compounds, the ionic compound, and then the other characteristic is that they are good. They are good conductors of heat and electricity. So good conductors of heat and electricity. So basically, this is what you need to know about the characteristics of these types of bond. Okay, and now let's move on to what is called covalent. Okay, it's a covalent bonding. So covalent bonding, so this is a type of bonding. And just say this bonding is a bonding that involves non-metals only. Okay, so it's a type of bonding that involves non-metals only. So what we mean by this is that, for example, when you go to the periodic table and you can have, for example, let's say nitrogen, okay, it's a gas combining with let's say oxygen. Okay, and then you can also have maybe just carbon dioxide. Okay, so we can have carbon dioxide. We can also have another example like the bonding that we find in ammonia, which is just like this one, and carbon dioxide is just CO2. So in the examples that I've given, all these exhibiting what is called covalent bonding. Now, this covalent bonding does not transfer, or rather does not lose or gain the electrons, but simply share. So the key concept is sharing the electrons. So share electrons. So they only share the electrons as opposed to the losing and gaining. Okay. So remember that in ionic bonding, so there is a losing on the gaining of electrons. So it's kind of this will be transferred to the nonmetal. So in the next video, we'll look at how that happens normally. Okay. Like I said, make sure you check the videos out. Some of these things are there. Okay. So now, what are some of the characteristics? Or some of the characteristics of covalent bonds or compounds. Okay, since we know that bonding forms compounds, so characteristics of this kind of bonds in this nonmetal. So the first thing is that involves the sharing. Involves the sharing of electrons. Involve the sharing of electrons and sharing of electrons between, okay, between nonmetals. So like for example, let's say in also you can say water, because is hydrogen and oxygen, hydrogen and oxygen. Okay. Then apart from that, they do not conduct, do not conduct electricity, okay, and heat. Okay, so they do not conduct electricity and heat, and they are, so some of them, they are liquid at room temperature. Okay, and so we are saying they're bad conductors of electricity and heat, so have low melting point. Low melting point. Okay, so they also have, weaker forces of attraction. So they have weaker forces of attraction. So for instance, when you have, and this is how you draw them, okay? Example, they only share the electrons, So let's say, for example, this is a carbon and this is the oxygen and oxygen. So this is like in carbon dioxide. So we shall come and look at how you can now just represent this kind of bonding. Okay. So now this is the key concept about chemical bonding. All you have to know is definition and also what are some of the characteristics of, the types and the characteristic of those types. Now the other bonding that you can find is also referred to as metallic bonding. So metallic bonding. So this is the bonding only found in metals. Only found in metals only. Okay. So only found in metals only. For instance, if you have something like a solid, you know that a metal is a solid stuff or matter, and you can have something like that. And then you can have the particles, these plus okay. So since the metallic bonding is just within a single element, for example, ion, okay, with a symbol, that one, ion. So all you can show is that the positive, because these are static, they do not move, okay. So that's normally what happens, or this is how you can present a metallic bonding in metals. Okay. So for your purpose of the exam, this is what you need to know. So thank you so much. So our next video will just now consider how you can go about the ionic bonding, drawing them, showing them, and also the same thing in this carbon dioxide. Okay. So the main purpose of bonding is to balance up these things that are shared. So just to give you a sense of purpose, carbon has got 6 electrons. Then once you configure them, you're going to have, let's say 2 and 4. So meaning the number of electrons that to participate in this sharing will be just 4. So you're going to put 2 there, okay, on each side that is shared, okay. And then for the oxygen, it is 8. So when you do the configuration is 2, then we subtract 2 from 8, that's going to be just 6. So for the oxygen, that will be 6. So we'll put 2 there, okay, 2 there for example, okay. Then also this is another oxygen, so put 2 for this one. Remember we have 2 oxygen, so it is 2, 6 again. So the other 2 will now bound, the other 4 will now bound these shells. So that at the end of the day, the idea is when I count this circle, I need to have 8 electrons altogether. So this is 1, 2, 3, 4, 5, 6, 7, 8. And when I count this for the carbon, I need to have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And also just along this oxygen. So since the the shaded ones represent oxygen. So you have 4 of them. Okay, so that is basically how you can go about that one. So lastly, I think didn't talk about so when you talk about electronic configuration, we are just trying to configure the electrons of those elements or atoms. So, for example, if I give you oxygen, okay, and it has a symbol of O, and on top there is 16, down there is 8. So when it comes to electronic configuration, you consider the number at the bottom. So I'm going to partition this number 8. So whenever you're partitioning, you always start with 2, and then now you ask yourself, you remove the 2 from the 8, you remain with 6. So this is the configuration for oxygen. Now this number, the 6, is the group number, okay? The group number of oxygen. And then this number, there are 2 partitions. So these 2 partitions simply means the period to which oxygen is normally found. Okay, so that's what you need to understand. So if I go to the periodic table, and then you find that it contains these lines. Okay, so let's say this is period 5, period 6, period 7, for example. So these are vertical ones or the columns. So these are columns, okay? These are columns. These are columns, also called the groups. And then these horizontal ones, okay? These are called the horizontal lines. So horizontal, also known as the period. So the electronic configuration for each element is going to give you information concerning the periodicity of that element, the periodic table information. So in this case, oxygen, the last number is the group number. So oxygen is found in group 6, this vertical column, this vertical column. And then these partitions, they are 2, meaning 2 and 6. So oxygen is found in period 2. In fact, it's supposed to be here. So period 2, we mean 1, 2, then group 6. So it's going to be here. So you can also do the same with sodium, which has got 23 and 11. So whenever you're partitioning, you look at the bottom number, and that is 11. So you're going to say it's 2, and then 8, and then 1. So when you add all these numbers together, you should get 11. So the last number is a group, and these partitions tells you to say sodium is in period 3. So meaning sodium is just after oxygen, period 1, period 2, period 3, like period 1, period 2, period 3. So under this, but in group 1. So the last number is a group number. Okay, so thank you so much. That is how you can go about electronic configuration. So the homework is that I want you to do the electronic configuration for magnesium, and then also for nitrogen, and then also for calcium and potassium. Okay, so check out on your periodic table and find that you are able to do this configuration. So thank you so much, and I'll see you in the next session. Thank you so much.